Okay, so today we are talking about electrolysis. Here's an example of an electrolysis problem. Given this equation, copper chloride in liquid form, it yields copper in liquid form and chlorine gas. Here's 3 questions. What are the anodes and the cathodes? What is the cell potential of the reaction? And what is delta G of the equation and reaction? This is a lot of information and a lot of questions to answer. So I'm going to take this slow and steady. To know what electrolysis is, here's a definition. It's pretty long, but I'll try summarizing as much as I can. Electrolysis is the process where an electric current passes through an electrolyte with subsequent migration of positively and negatively charged ions to the anode and cathode, and that is electricity is used to create a chemical change that does not normally happen. In other words, electrons are passing through some sort of some object, and it's creating a process that does not usually occur. The reason why I have non-spontaneous highlighted or just in other words, in large words, is because non-spontaneous means it doesn't happen normally. So in order to create a reaction, in order for this process to work, to create a non-spontaneous reaction, you need an electric source. You need a strong enough electric source to force this reaction to happen. So we're going to use an electric battery. Because the electric battery is powerful, the energy should be strong enough to force the reaction to happen. Okay, so the first question. What is the anode and the cathode? Here's the definition of the cathode and the anode. The cathode is the electrode that is negatively charged, and the anode is the electrode that's positively charged. In order to find the cathode and the anode, we have to do oxidation numbers. As you can see here, copper has a charge of +2, and chlorine has a charge of -1. The battery is going to force this reaction to happen because copper doesn't want to gain electrons, and chlorine doesn't want to lose them. So as you can see from here, the formal charge of copper turns from 2 to 0, and for chlorine it turns from -1 to 0. We can say that copper is gaining electrons because it's becoming slightly more negative, and chlorine is losing electrons because it's more positive. Copper is going through a process known as reduction. Reduction is when an element gains electrons and becomes slightly more negative. Chlorine, however, is going through oxidation, which is losing electrons. From what you can see, from what you can learn from here and from the definition, copper is the cathode because it's gaining more electrons, and chlorine is losing electrons, so it is considered the anode. Right now, we have a diagram and some equations. These reactions here, it shows the reduction reaction and the oxidation reaction. As you can see here, the copper is gaining electrons, and chlorine is losing. From this diagram here is an electrolytic cell. As you can see here, the chlorine. Here's a battery. Here's molten copper chloride, because in order for this process to happen, copper chloride needs to be liquid. It has to be molten. And if I remember correctly, the temperature from the melting point is around 500 degrees Celsius or 900 degrees Fahrenheit. From the cathode side, the battery here, it pulls these electrons from the copper ion. Wrong area. My bad. The oxidation one. This takes the electron. The battery takes the positive side of the battery takes the electrons and pulls it to the battery. These copper ions become gaseous copper. and this is losing mass because this chlorine gas, they're going up into the air. On the other side, the battery just pushes these electrons to the copper, therefore the copper becoming more negative. Okay, question 2. How are you going to find the cell potential? Well, the cell potential is E of the cell. The reaction, in order to find the east of the cell, you have to do the east of cell of the reduction, the cathode, and minus the reduction of the anode. So, in order to find that, we have to use a reduction or oxidation table, which apparently I don't have, in order to find the reduction of these half equations. As you can see from the previous slide here, you have the reduction and half reaction, and the oxidation half reaction. In order to get the half reaction for the oxidation, you have to flip this reaction around. So the reactions for the cell potential are here and here. As you can see here, like I said, this becomes this. So when you do the math, when you plug in numbers, you get this, and your standard cell potential becomes negative 1.02 volts. Now we get to the final question. What is the delta G? Delta G is very similar to thermochemistry, but there's a catch. Because the reaction's not spontaneous, delta G has to be positive. And the fun fact is, to find the delta G of an electrolytic cell, it's similar to a voltaic cell, and here is the reaction. Delta G equals negative N, which is the moles of electrons, times Faraday's constant, times the cell potential. In order to the cell potential becomes the voltage you find from the cell potential. Because it's converted to volts, this negative 1.02 volts, it becomes negative 1.02 joules per coulomb. So if I can find my reactions here, here's the whole reaction of delta G. As you can see from this equation, from the half reactions of finding copper and chloride, you have 2 electrons. And then you're multiplying it by Faraday's constant, which is 96,485 coulombs per mole. Then you multiply it by negative 1.02. From this reaction, when you take account into sig figs, you get 197,000 joules. And then because delta G is to be in terms of kilojoules, you get 197 kilojoules.